Okay, so today we're going to finish up Chapter 5, Section 2. So we'll finish the notes. So on this slide, remember you need to memorize the relationship of what goes into the 6 trigonometric functions. Remember I told you on Friday, y should you sin? So think of the y going with sine. So sine is y over r. Its reciprocal is cosecant. So just flip it and it's r over y. Cosine is going to be x over r. Its reciprocal is secant. So flip it to r over x. Tangent is y over x. And then cotangent is x over y, the reciprocal. Remember the little acronym I taught you about? All students take calculus. And this will help you to remember which one of the functions are positive and which one of the quadrants. Also be able to take an order pair and find the value of those 6 trig functions, plugging them into that previous slide. Remember, in an order pair, the first number is x, the second number is y, and then you just had to use this formula to get your r value, which is basically the Pythagorean theorem, but with different letters. And then here were the quadrant angles. So remember, whenever you're trying to find the value of a 90-degree angle, you would use the order pair 0, 1. If it were 180, -1, 0. And then 270, 0, -1. Over here would be the 0 and the 360. And that would be the order pair you would use. You're not drawing triangles for these quadrant angles. You're just going to use those order pairs. Next, we saw the reciprocal identities. So again, remember, sine is the reciprocal of cosecant, cosine is secant, and then tangent is cotangent. And then we learned how to use the reciprocal identities. So remember, these two are reciprocals. So if they give us secant to find cosine, all I have to do is flip the fraction. So since secant was 5/3, cosine would be 3/5. Now on the next one, when we did it, the radical ended up in the denominator. And remember, whenever you have a square root in the bottom of a fraction, you must rationalize. Which leaves us to where we left off on Friday. And the first box there is for the solution intervals. Now, if you think about this logically, these solution intervals will help you if you ever do something on your calculator and you get error. It'll help you to give you the confidence to realize, wait a minute, the reason why I'm getting an error is because it's undefined for that angle. So for example, for sine and cosine, I know we talked about this on Friday, but for sine and cosine, remember, if you think back to your geometry days, sine was always opposite over hypotenuse, and cosine was adjacent over hypotenuse. And if you remember, the hypotenuse is always the biggest side of the triangle. So really what we're putting in here is a smaller number over a bigger number. So this is why sine and cosine right here, it's always going to be a fraction. It's going to be a number between -1 and +1. So if you ever get a question like, find the sine, find the angle for sine when it equals 2. Well, if you remember, sine can only be between -1 and +1. So when you do this on your calculator and you do the second sine and put 2, you're going to get error because this is impossible because sine cannot have a value of 2. However, if I said find theta when sine equals 1/2, this would be possible because it is in the range of -1 to +1. And then the second restriction here for secant and cosecant, these are going to be numbers that are greater than 1 or less than -1. Because if you think about it and you flip the fraction for cosecant, now the hypotenuse is in the top and the opposite, the smaller side's in the bottom. So this is why whenever you're doing cosecant or secant, it's always going to be an improper fraction. The bigger number is going to be on top of the smaller number. So that's why it's going to be a number greater than 1, but less than or equal to -1. And it could be equal to 1. And then the last thing that they're showing here is that tangent and cotangent, depending on what your opposite and adjacent sides are, it could be a regular fraction or an improper fraction. So that's why it's all real numbers. Tangent and cotangent could be anything. Now, the Pythagorean identities, these are down here. We are going to be using these a lot. And again, these are the 3 basic ones, but be able to take any of the 3 and rearrange them and solve them for any part. So let's say I wanted to maybe do a substitution for sine squared theta. So in that case, I might want to rearrange it and get sine by itself by subtracting cosine squared from both sides. And then I get what sine squared theta equals. It equals 1 minus cosine squared theta. So be able to manipulate them, move things from one side to the other on any of the 3. And then the last thing that's in here are the quotient identities. We're not going to be using the quotient identities for the quiz, but just know that they're presented here. And it's going to be sine squared, or just sine theta over cosine theta equals tangent, and then flip it, and it's cosine theta over sine theta equals cotangent. So we'll be using these identities a lot coming up, but for the quiz, we're only going to be using the reciprocal and the Pythagorean identities. Okay, so again, the instructions say to use the Pythagorean identities to find the following. So the Pythagorean identities that we're going to be using for these problems are going to be the 3 from the previous slide. We're going to be using the sine squared theta plus cosine squared theta equals 1. And then the next one is tan squared theta plus 1 equals secant squared theta. And then the third one is 1 plus cotangent squared theta equals cosecant theta. So now, to determine which one of the 3 I need to use, I'm going to look in my problem to see what was given to me. And notice what was given to me was tangent. So the identity I'm going to use is the second one here. So I'm going to be using tan squared theta plus 1 equals secant squared theta. Now, also notice the restriction. They're telling me that theta is going to be in quadrant 3. So this is where my all students take calculus comes into play. Now remember, in quadrant 3, the only positive functions are going to be tangent and cotangent. The other 4 are going to be negative. Notice the tangent they gave me is positive. However, I'm looking for sine and cosine. So remember, sine and cosine in quadrant 3 are going to be negative. So this is a way that you can confirm that your answers need to be negative once we're done. So now, I'm going to take what they gave me, that tangent equals. Tangent equals 4/3. So I'm going to take out my tangent squared theta. I'm going to put 4/3, and I have to square it. And then I put the plus 1 equals secant squared theta. I need to add these fractions. So I'm going to square it first. So I get 16 over 9. Now I need to add these fractions. So I'm going to change my whole number 1. And I'm going to make it 9 over 9. And then it equals secant squared theta. I need to add my fractions. 16 plus 9 is 25. Keep the same denominator. And now I don't want secant squared, I just want secant. So I need to square root both sides. And then if you want to think of this as doing the square root of 25 and then the square root of 9, you can do that. This gives me 5 over 3 plus or minus equals secant of theta. Now, here's where my all students take calculus comes into play. In quadrant number 3, remember the only thing that's positive is tangent and cotangent. So that tells me secant needs to be negative in quadrant 3. So I'm only going to keep the negative 5/3 for quadrant 3. Now, the question didn't say find secant. Remember, it said to find sine and cosine. Remember, secant is the reciprocal to cosine. So now to find cosine of theta, all I need to do is flip my fraction. Now for sine, I need to do a second identity. So now for sine, what we're going to do is I'm going to take the identity sine squared theta plus cosine squared theta equals 1. I'm going to take my newly found value of cosine and I'm going to plug it in. So I'm going to leave sine squared theta, take out cosine squared theta, put the negative 3/5 and square it, and it's equal to 1. I need to square 3/5. So sine squared theta equals 9/25, or not equals, sorry, plus 9/25 equals 1. Now, again, I need to move my 9/25 to the other side to isolate the sine squared theta. I'm going to change this whole number 1, and I'm going to make it 25/25, so I can subtract my fractions. So then now I have sine squared theta equals 16/25. I don't want sine squared, I just want sine. So square root both sides. And sine of theta is equal to 4/5, plus or minus. But I only keep the minus because I'm in quadrant 3. And there are my 2 answers. You must use the identities to solve this question on the quiz on Wednesday. Now I'm going to show you a shortcut. What you could do to check your answer. So what you can do to check your answer on the quiz is, remember, they gave us tangent of theta was equal to 4/3. Remember, and we're in quadrant 3. Remember, the signs on the order pair in quadrant 3 are going to be negative, negative. Remember, tangent is y/x. So really what went into this was a -4 over a -3. So my x is -3, my y is -4, and then to find r, all we have to do is x squared plus y squared, square root it, and then we would get -3 squared plus -4 squared, 9 plus 16, 25, square root it, and your radius is 5. So now the question said, find sine. Remember, sine is y/r. So if you just do -4 over 5, and then cosine is x/r, -3/5, and it's the same answers I got when I did all the work using the identities. This is how you can check your answer. If you use this to solve the question and you don't have the identity work, but you get the right answer, it's still wrong. You must use identities. All right, so for number 6, they want me to find cosecant. And they're giving me cotangent. And it's in, theta is in quadrant 4. So all students take calculus. Remember, in quadrant 4, cosine and secant, these are the only positive ones. So cosecant is going to be a negative answer. Now, I'm going to go up and see my 3 identities. And notice out of the 3, the one that I need to use, because they gave me cotangent and I'm looking for cosecant, I'm going to be using the bottom one. The 1 plus cotangent squared theta equals cosecant squared theta. Let me come down here where I wrote the problem. So the identity I'm using is 1 plus cotangent squared theta equals cosecant squared theta. So now I'm going to replace what they gave me. I'm going to take out cotangent, and I'm going to put in negative 1/2, but I have to square it. Rewrite the rest of the problem. Negative 1/2 squared gives me positive 1/4. Now, do not be tempted to make this a mixed number or a decimal. Leave it improper because we got to square root it. So what we're going to do is I could change my whole number 1 here and make it 4/4. So then I get 5/4 is equal to cosecant squared theta. I need to square root it. So again, remember, I can do them separately. So then this gives me positive and negative square root 5/2 is equal to cosecant theta. Now, that's all we wanted to find, but we got to figure out which one do we keep, the positive or the negative? Negative. And we keep the negative because we're in quadrant 4. So negative square root 5/2 is equal to cosecant of theta. All right, so remember, for your all students take calculus. So for here, all 6 are positive. So sine, its reciprocal, cosine, its reciprocal, and tangent and its reciprocal, these are all positive. Now over here, for the S in students, this is going to be sine and cosecant are positive, but cosine, secant, tangent, cotangent, these are going to be negative. And then in this quadrant, the T stands for tangent and cotangent. These will be the positive ones. And then the negative ones will be sine, cosecant, cosine, and secant. Those will be the negative ones. And then over here, for the calculus, that'll be the C. So cosine and secant are going to be the positive ones, and then the negative ones will be sine and cosecant, and then tangent and cotangent. Those will be the negatives. So on this one, our order pair, this is our X and our Y. We can still find the R by doing X squared plus Y squared, and then square root it. So negative 4 squared plus 0 squared. This will give me 16 plus 0. And then when you square root 16, your R value is 4. So we have X equals negative 4, Y equals 0. Now, we can choose to do it just like we did at the beginning. And then we can go ahead and if you think about it, what we're really finding here if I go ahead and graph this order pair, 1, 2, 3, 4, it's the order pair right here. So really what we're doing is finding the 6 trig functions for a 180-degree angle. Now, when I talked about finding the values for these quadrant angles, remember I told you you could use the first order pair here on each one. Remember I told you could use the order pair 1, 0 for the 0 and the 360. This one would be 0, 1. This one, you could use this one, -1, 0. And then this one here for the 270 would be 0, -1. So anytime your order pair lies on the X or the Y axis, you don't necessarily have to use the order pair they gave you. You could use this very first one that it's hitting. Because when I make a 180-degree angle, I could just come around here and I could also stop at this order pair. So it's up to you. If you want to use these 3 numbers for your X, Y, and R, you can. You could also do it using the -1 for X, the 0 for Y, and remember, whenever you use that first order pair, your R value is always 1. Now, what you're going to see is even if I use the -4 and the +4, I'm going to get the same answer. I just have to simplify my fractions. It's just the angle that's formed. So this would be your initial side. Let me use a different color. This is the initial, and then standard position would be coming around here to the terminal side. So now that I have my X, Y, and R, I can go ahead and I can either choose to do these. So if I do sine of theta, but I can already see that my theta is going to be 180 here. So remember, sine, y should use sin, y over r. So 0 over 4, and that's 0. Then for its reciprocal, cosecant, flip it, r over y. And then this is going to give you 4 over 0, undefined. Then if you do cosine of 180, cosine is the x over r, so -4 over 4, -1. Its reciprocal, secant, r over x, 4 over -4, -1. Same answer. And then lastly, tangent and its reciprocal, y over x. So y was 0, x was -4, so that's 0. And then cotangent, its reciprocal, flip it. So I'll have degrees. X over y, -4 over 0, undefined. Now, you can do it using the given order pair, but again, you could also have done it using the order pair -1, 0, that first order pair. And then the R value is always 1. So if you would have done sine using that order pair, y over r, using that order pair, you would get 0 over 1, which is 0. Notice it's the same answer I got here. And then if I flip it, r over y, 1 over 0, undefined. And then cosine 180, x over r, -1 over 1, -1. Notice it's the same answer I got here. I just had to reduce it. So again, you can use the -1, 0, or use the given order pair. Secant, the same thing's going to happen. R over x, 1 over -1, -1 as well. And then tangent, y over x, 0 over 1, -1, which is 0. And then cotangent, flip it, -1 over 0, undefined. All the same answers I got. Okay, So for these types of questions, you need to figure out what each part is. So first we had to find the secant of 180. And again, whenever it is one of those angles that are on the axis, the quadrant angles, we're going to use the order pair 1, 0 for the 360. And then for the 180, we're going to use the -1, 0. So secant is the reciprocal of cosine. So it's r over x. So my r value, whenever I'm doing these quadrant angles, is always a 1. So 1 over -1, which simplifies to -1. And then that's what I took and I plugged in over here for my secant of 180. I'm going to multiply that by the 3. But I also have to find the tangent of 360. So tangent is y over x. So the order pair for tangent is going to be the order pair right here, the 1, 0. So this is x, this is y. So y over x is 0 over 1, which is 0. So then I went ahead and multiplied -5 times 0. So then I end up with -3 minus 0. And the final answer here is just -3. I'm going to do exactly the same thing on number 9. I already found the tangent of 360. That's going to be 0. So 0 plus. I need to go back and do sine of 180. So remember, the 180 order pair is the -1, 0. So sine of 180 is x over r. So -1 over 1. I take that back. It is sine. Why should I sin? Yes.
Why should you sin?
Yes, why should you sin? So remember, this is a y over r. So this is a 0 over 1. So sine of 180 is 0. So here we're doing 4 times 0. And then cosine, this is where I use the x. So cosine of 180, x over r. So this is going to be the -1 over 1, which is equal to -1. So I'm going to plug it in here. 2 times -1 squared, because it's cosine squared. So then here, this gives me 0, 0. And then 1 squared is 1. So then the final answer is just 2 times 1. So the final answer is 2. So on the homework, you're going to get a question and they're going to say, find which quadrant is located, or find which quadrant theta is located in. So they're going to give you when sine of theta is greater than 0 and cosine of theta is greater than 0. So what this means to me is when something's greater than 0, it's positive. If it had when cosine of theta is less than 0, this is where I would look where cosine's negative. So what you're going to do is you're going to do your, so this is the question we're going to answer right here. So you're going to do your little axis here, and you're going to do your all students take calculus, and then I'm going to put check marks where sine is positive. So I know sine is positive in quadrant 1 because everything's positive in quadrant 1. And then the S, that stands for sine. So it's also positive in quadrant 2. Then I'm going to go and I'm going to find where cosine is positive. I know cosine is positive in quadrant 1 and in quadrant 4. So the answer to this question, the quadrant where you see 2 check marks, is the answer to the problem. So it will be positive, both of those, in quadrant number 1.